Good morning, everyone, and a warm welcome for today's session on lightning in the Vismaya Vigyana YouTube webinar series organized by CSIR 4th Paradigm Institute, Bengaluru. It is my privilege to introduce our distinguished speaker, Dr. Konatham Prasanna, scientist in the Interdisciplinary Data Research Division at CSIR 4PI. Dr. Prasanna holds a PhD in Meteorology and Atmospheric Science from Andhra University in collaboration with the Indian Institute of Tropical Meteorology, Pune. Her academic and research journey reflects an impressive breadth across diverse domains, including monsoon dynamics and variability, atmospheric electricity and lightning phenomena, greenhouse gas monitoring and modeling, ocean biogeochemical processes, and air-sea interactions. She has contributed to numerous peer-reviewed journals and has been recognized with several honors, including the DST Inspire Fellowship, CSIR UGC Net, and Dr. D.W. Desai Gold Medal. In today's webinar, Dr. Prasanna will take us on an illuminating journey into the world of lightning, exploring how thunderstorm clouds form, what causes the generation of charges within them, and how lightning originates from these complex atmospheric interactions. She will also touch upon types of lightning, their effects, and most crucially, safety measures to be aware of during lightning events. This session promises to be both educational and inspiring, especially for students, educators, and young researchers interested in atmospheric sciences and extreme weather events. Please join me in welcoming Dr. Konatham Prasanna. Over to you, madam.
Thank you, Ms. Reena, for the nice brief introduction. I also thanks to CSIR4PI and Jigyasa team for giving this nice opportunity. So, before good morning and a warm welcome to all the students joining us today for the first part of Lightning webinar series. This session is designed especially for school children to help them understand one of the nature's most exciting and powerful phenomena, lightning. What it is, why it causes, and how to stay safe during a thunderstorm. Before starting today's session, I would like to give a brief note on why lightning studies are more important in India. So, lightning is one of the dangerous phenomena. So, India is the hotspot region for lightning. It causes more than 2,500 deaths annually due to 20 million lightning strikes annually. It accounts for 35 to 40% of the all weather related deaths in India. Most lightning affected regions are rural areas where people work in the field. They cannot access to early warnings and safe shelter. So lightning is more prone in the rural and agricultural regions. Also, school going children are also more affected by lightning especially during monsoon seasons. Up to 90% of these events can be prevented with safety measures, early warnings, and safe infrastructure and awareness. So, without further delay, let's start our today's session on lightning. You all might hear thunder and see lightning, but how many of us know what exactly is lightning and why does it happen? Let's find out together. Let's start with a simple question. What is lightning? Lightning is nothing but a giant spark of electricity that generates during a thunderstorm, which is caused by the imbalances of electric charges between different storm clouds or cloud and the ground. So lightning is happen during a thunderstorm, which means thunderstorm is initiates lightning. But the question arises, what is a thunderstorm? A thunderstorm is a weather phenomena characterized by heavy rain and wind, thunder, and of course lightning. While how does a thunderstorm begins? It all starts with the sun. How? Let's find out together. The sun hits the surface of the earth. As the heated surface warms the air just above it through conduction. Conduction is nothing but the transfer of heat between molecules through direct contact. So as the air warms, it becomes less dense. When air is heated, the molecules gain kinetic energy and move faster, collide more frequently, leading to the air parcel to expand and molecules to spread out. This reduces the number of molecules per unit volume and results in a lower density. So now the air above the surface is warmer and lighter. As the warm air parcel has more capacity to hold water vapor molecules, as the composition of the atmosphere is made up of mostly nitrogen and oxygen. When air parcel becomes moist, these nitrogen and oxygen molecules will be replaced by water vapor molecules. The molecular weight of water vapor is very less compared to nitrogen and oxygen. It is just 18, while nitrogen and oxygen is 28 and 32 respectively. So because of this lower molecular weight of water vapor, the moist air is very less dense than compared to dry air. Now the warm moist surface air is forced to rise as long as it weighs less and stays warmer than its surroundings. Now so far we have seen how sun is responsible for an air parcel to rise, right? Now let's look at how thunderstorm cloud forms and evolves from this rising air parcel. So as the air rises, it transfers heat from the surface of the earth to the upper levels of the atmosphere. This process is called convection. So convection is the primary process that initiates the thunderstorm development. As the air goes higher into the atmosphere, the temperature of the air parcel reduces due to the adiabatic expansion and the lower atmospheric pressure. When the air parcel rises up and up, it cools down at dew point and when it attains 100% relative humidity. When it attains 100% relative humidity, the air parcel cannot hold more water vapor molecules in the gaseous form. So some of the water vapor molecules condenses into tiny water droplets. These water droplets gather together and form as a white puffy cloud. This cloud is called cumulus cloud. So the formation of cumulus cloud is the first stage in the development of a thunderstorm. This stage is called cumulus stage, and at this stage we can see only the rising air motion. These rising air motions are scientifically termed as updrafts. Once the cloud is formed, it eventually grows further upward into the areas where the temperature is very low. In the atmosphere, both temperature and pressure decreases with height. So when the cloud grows up, it reaches the low temperature regions. As the storm rises into the freezing air, different types of ice particles can be formed from the supercooled liquid water droplets. So these ice particles can be ice crystals and graupel. Ice crystals are nothing but they directly form through the freezing of supercooled liquid water droplets. Once these ice crystals are formed, some of the additional supercooled liquid droplets may freeze upon the ice crystals. This leads to the formation of graupel. So at this stage, now the cloud is full of tiny water droplets, ice crystals and graupel. So different sized particles move around at different speeds in different directions due to the vigorous vertical movements caused by updrafts and downdrafts. So this turbulent motion causes ice particles to collide more frequently. So when two ice particles collide, they usually bounce off each other, but one particle can rip some of its ice from the other one and grab some electric charge. So lots of these collisions build up a big regions of electric charges. So this is how charge distribution is in a thunderstorm cloud. There are many positive and negative charges present in the thunderstorm cloud. Now let's see how different charges are generated for different particles. When an ice, let's say we consider ice crystal collide with a grapple. We heard that ice crystal is formed through the direct freezing of supercooled water droplets, while grapple formed through the rimming of ice crystal. So ice crystal collide with grapple. Ice crystal is more likely to lose ice, while grapple tend to gain ice. So as the ice crystal lost some of its ice, it lost some of its electrons and gain a net positive charge, while grapple gain that negative charge and take on a net negative charge. Let's explain it by considering the atomic structure. So the electrons are present in the outer ring of an atom, so they are weakly bounded with nucleus, while protons are tightly bounded with the nucleus. They cannot escape from nucleus very easily without having high energy, but electrons can easily transferable between two atoms. So when ice crystal collide with grapple, some of its electrons may lose. So this results net positive charge to the ice crystal and net negative charge to the grapple. Now, once a big regions of positive and negative charges are formed, how these charges are separated in the cloud? As air currents move upward and water droplets move downward, these vigorous movements cause charge separation to occur in the mature stage. So, lighter and smaller positively charged small tiny water droplets and ice crystals move upward through updrafts, and heavier and larger negatively charged grapple settle down at the bottom. So it results a bunch of positive charges at the top of the cloud and negative charges at the bottom of the cloud. Now, once the charge separation is happened, how lightning is born from these charges? So, after a lots of collisions, multiple positive and negative charges will be formed. Once these charges are bigger and bigger, the magnitude of these accumulated charges become very large. The air is basically a poor conductor because the air molecules are widely spreaded, and it is made up of inert gases. It cannot facilitate the transfer of electric charges between the molecules. So it cannot resist their flow once these charges build up very large. So a giant spark of lightning occurs between positive and negative charge. This positive and negative charge can initiate lightning. This lightning can initiate between any positive and negative charge. The positive charge of one cloud to the negative charge of another cloud, or positive charge and negative charge of the same cloud, or positive charge of cloud to the negative charge of ground. It can happen in many ways. So based on the initiation of lightning, the lightning can be classified into three different ways. When lightning initiates and terminates in the same thunderstorm cloud, then this type of lightning is called intra-cloud lightning. But when lightning initiates in one thunderstorm cloud and terminates in the other thunderstorm cloud, then this type of lightning is called cloud-to-cloud lightning. When lightning originates in one thunderstorm cloud and terminates on the earth's surface, then this type of lightning is called cloud to ground lightning. So once lightning occurs, what are the effects environment and society is facing because of this lightning? So there are a wide range of serious injuries and even deaths caused due to lightning to humans and livestock. The different types of injuries may include skin burn, cardiac arrest, hearing and vision loss, and nervous and brain damage. It can also cause damage to power infrastructure and properties. The high amount of heat released during a lightning can ignite forest fires. It can also cause air pollution through the formation of nitrogen oxides. Now, how to be stay safe during a thunderstorm? So if thunderstorm happens, you catch up on outdoors, and in some minutes it is going to lightning and thunder. So how to stay safe? Try to stay safe as early as possible to get into a shelter, and this shelter should be closed and it has hard top. It can be a building or a car also. and try to avoid open fields and hilly regions, and try to stay away from the tall isolated objects, and also do not touch electronic conductors like water, wet items and metals. Try to take a crouch position. Some of these measures can relatively reduce the risk of lightning. Now the tall objects can easily affected by the lightning strikes. So how the buildings and equipments can be stay safe from these lightning strikes? We are having some lightning devices which can really protect the structure from the lightning strikes. Let's explore some of them. Lightning rod is nothing but a metal rod which is made up of copper or aluminum, which is placed on the top of the building to protect building from the direct lightning strikes. When lightning strikes, the rod gives the electricity a safe path to travel into the ground, whereas lightning arrestor is used to protect electronic equipment from lightning voltage surge. It blocks the extra voltage caused by lightning from entering into the electronic gadgets like computers, mobiles, TVs, etc., which is basically installed on lightning poles, telecom towers and near power stations. So today we have uncovered the fascinating science behind the thunderstorm, how clouds build up charge, and how the lightning is born from these charges, and most importantly, what are the safety measures have to be taken during a thunderstorm. And we have also seen how nature's power can be more dangerous if we are not careful. Uh, with the right understanding and safety measures, we can protect ourselves and our surroundings. In next session we will take this further, looking at where lightning is occurring more frequent in the world and in India, and also we explore what are the modern devices and tools, sensors, techniques available to detect and predict lightning. So
Thank you, Dr. Prasanna, for that fascinating and insightful session. Your talk has truly illuminated the science behind lightning, from the formation of thunderclouds to the dynamics of charge generation and lightning initiation. The clear explanation of the different types of lightning, their impacts, and most importantly, the safety measures made this session not only informative but also practically valuable. On behalf of CSIR 4PI and Jigyasa team, we sincerely thank you for sharing your expertise with us today. To our viewers, thank you for your active participation. We hope you found today's session engaging and educational. Join us again for day 2, where we will continue exploring more aspects of lightning. Until then, stay safe, stay curious, and keep exploring the wonders of science. Have a great day. Thank you.